And we had a project that was called CATWOMAN. So there's Martin Hundebol, he was one of the implementer who really brought this idea even to the Linux kernel. So from Linux kernel 3.1, if there's Batman routing in it, you can also switch on the XOR coding. And we did also other work with our collaborators where we had tried to understand some theoretical part in where does the gains come from, where are the things that does not work so well. You will see it now. It was used on different platforms, right? Nowadays, I think you would use Raspberry Pis, Odroids with a USB dongle, very easy to build this up. At the time, we had some OWRT devices. They used the Batman routing. So just to say what routing, you have 3 different routing schemes mainly in wireless mesh. AODV, OLSR, and Batman. The first 2 are an RFC, and the Batman is just an implementation. From our point of view, that's the best, and we also got in touch with the people that did Batman, and we wanted to use something on top of Batman, right? Which was then, of course, a coded version, and that was called CATWOMAN, right? There is a group of people that think about wireless mesh. They have a battle mesh where they always come together and try to find out what is the best solution for wireless mesh. And the people that did the Batman, part of them are now here as a PhD students working on a more advanced way of doing the coding, right? This was the first stepping point into this. So what we wanted to say is Alice and Bob, right? We had 3 devices. We just said, okay, take 3 of them, do Alice and Bob, store forward should be 4, and the other one should be 3. We expect 33% of gain. But it's not Alice and Bob only. We have Alice, Bob, Charlie, and Dave. These are the small devices. The traffic itself was generated by a laptop because the small devices could not create so much traffic that would be overload. And then we said, okay, when we have this, we can do Alice and Bob, but we can do the X topology, cross with overhearing, without overhearing, and there's a test controller that collects all this stuff. And it was not artificial, it was at the university in Aalborg, where we had here 2 devices, and a relay, where these devices were on different floors. So this was the first, the ground floor, and this other one was the 3rd floor. It's really the X that we are looking for, right? And the problem, of course, as always, there are other students, and they're using Wi-Fi as well. So we have some interference over there. That are the different topologies that we will talk about. Alice and Bob, extended Alice and Bob, which means that the relay will only XOR packets of the same flow, and by that not create problems of robustness. If you need the overhearing, then it's more efficient, especially in the cross, in the coding, but there's vulnerability if you really lose one of the overhearing opportunities. Good. What we are doing then as a metric, we are looking throughput, losses, energy, and delay. That's where the most interesting parameters. You can come up with more than that. For example, security was not so important for us at the moment.